Yes, dear student, in this video again I will be telling you about resonance especially. This video is meant just to understand the significance of resonance in our life. Uh, I told you phenomena of force vibration. Every body, like simple pendulum, like mass attached to spring, has its frequency 1 upon 2 pi under root k by m is the frequency of mass attached to spring. This frequency depends on this mass and spring constant k and equal natural frequency. Similarly, pendulum, there are many oscillators in our life. I told you many times that communication is through electromagnetic wave and these waves are of different frequency and we tune our television or radio to a particular channel, whether you want to listen rainbow FM or some other Mirchi radio, etc. So that is done with the help of resonance. So what is resonance? It is the phenomena of force oscillation, phenomena of force vibration in which the frequency of applied periodic force is brought close to natural frequency. In that case, amplitude of vibration become maximum. In this case, we can illustrate this case of resonance here. Suppose here is a string, common string there, and we connect different pendulum 1, pendulum 2, pendulum 3, pendulum 4, pendulum 5. 1, 2, 3, 4, 5. These are simple pendulums of assorted length, mixed length. 1, 2, 3 अलग-अलग length हैं. Now, when we made to oscillate pendulum 1, you please read from NCERT book. I am telling here, I will not write anything on the board. When we make the pendulum 1 to oscillate, the pendulum 1 when oscillate it apply periodic force through the string, common string. When it oscillate, then string start vibrating and those vibration will apply external periodic force on pendulum 2, 3, 4, 5. These all pendulums start oscillating initially with the different frequencies because their frequency will be determined by this formula 1 upon 2 pi under root G by L. Longer the length, smaller the frequency. So pendulum 2 will have highest frequency, then lower than this will have the same length. Again same frequency, it will be again lower frequency. So initially all these pendulums will start oscillating with different frequency and gradually later on they start oscillating with the frequency of pendulum 1 because pendulum 1 is applying periodic force on pendulums 2, 3, 4, 5. So initially pendulum 2, 3, 4, 5 will start oscillating with different frequencies with their natural frequency. They will be different from the frequency of this, but frequency of 1 and 4 will be same. And later on, after some time, I told you that due to damping and the damping produced by applied periodic force, natural vibration of pendulum 2, 3 and 5 will die out. And these pendulums start oscillating all with the frequency of pendulum 1. That is case of force vibration. But here you see the length of pendulum 4 and 1 is same. So their frequency match. the driver frequency on 4 is the same, so frequency will remain same, and but amplitude will start increasing, and pendulum 4 here will have large amplitude oscillation, much more than that of 1, 2, 3, 5. This is the phenomenon of resonance. I hope you have got my point. रेजोनेंस को समझना बहुत ज़रूरी है। हमने कहा इन सब की लेंथ अलग अलग है, सिर्फ 1 और 4 के। तो when we apply periodic force by oscillating pendulum 1, all pendulum will start oscillating with different frequencies. Frequency of 4 will be equal to 1 initially, but very soon the natural vibration due to damping produced by the damping force present where the strings are tied and damping produced by applied force, the natural vibrations stop and all start oscillating frequency of pendulum 1. But in that one, the behavior of pendulum 4 will be different. It will start picking amplitude larger and larger and will become sufficiently large amplitude. So pendulum 1 and 4 are in resonance condition. Pendulum 4 is in resonance condition with 1. This thing is made here in our television radio circuit. The electromagnetic wave which our antenna receive has many frequencies. In our television or radio set we have electric circuit where we produce an electric current whose frequency can be varied by some factors. When frequency of current in the circuit of television or radio matches with frequency of any channel, then for that particular channel the current will be maximum and we get the light picture and sound larger amplitude and other get diminished like that. Now similarly, natural frequency. Any body which can vibrate may have many natural frequencies, not single one. We will learn in coming chapter when we have a rod or a string here. Along with the fundamental frequency, it may have many frequencies of oscillation. Now some applied periodic force is applied on this, and if any one frequency matches with the frequency of applied force, then it may oscillate with larger amplitude. So like our buildings are there, they have different heights. When earthquake occurs, seismic wave made the building to oscillate, but they do not cause equal damage to all buildings. Why? Because frequency of different natural frequency will depend on height and may have different frequencies. Now if any frequency of the building matches with the frequency of seismic wave, then for that there will be large amplitude and the building may be damaged. The same way, when some military is passing over a suspension bridge. You know what is suspension bridge? The bridge which stay only on the ends and it is free here, like Lakshman Jhola. So when any military passes over any suspension bridge, they go out of steps. They are asked to stop the marching and move randomly. Why? Because when they move, their step produce vibration, and the bridge has its own many natural frequencies. Single frequency is not always there in any oscillating body. My sound, I am producing sound, my I'm producing vibration, but my sound is not a single frequency. So if any frequency of bridge matches with the frequency of foots, then amplitude of oscillation may be large and the bridge may be damaged. So that way there are many other examples in other book. It was written there. Okay, one bridge was constructed another same night it was broken due to wind's frequency. So this is the last topic of this chapter. Please learn the resonance properly, learn the phenomena of free oscillations and damped oscillation very carefully, because people don't, teachers leave this topic, simply they tell okay, what is resonance, and people keep on struggling in coming chapters, because resonance will come at many places. Now we have a practical in class 11, resonance tube. We will learn here now, chapter coming wave, a very good chapter is waiting you. Wave chapter है ना, तो वो chapter बहुत wave chapter very important. And dear friend, I am telling you again and again that unfortunately we do not study this chapter, last chapter, very carefully and don't understand that. Book says something, we understand something other. In case of wave, people don't know. Once I was sitting with a very learned person, very intelligent person, and he discussed with me very long back. Something he was discussing with me. I said, sir, when we read the book, book says something other, we understand something different. He said, then how? I told them the concept of wave is not clear. When idea of wave is introduced, we get something going like this. Something is happening like this, that is wave. So concept comes when wave is there, then wave go like this. No. I said this is not there. I explained him and he instantly said, ask me to write a book on this topic. But I am unable to write, this is my weakness. That's why I have started my lecture on YouTube. So please ask your friend and your classmates, if you have in contact and you are getting my lectures properly, ask them to subscribe. I am doing work for those students who cannot reach a teacher and who are in trouble with different topics. One my student told me, a student was there who was not able to understand electromagnetic wave. He listened he watched my videos and he was very happy. Okay, bye. In this chapter, I have done many numericals also, and you please take care of this chapter. Do more numericals from different competitive exam, and I hope you will do better. Thank you.